Okay, so in this video, we're going to go ahead and talk about this idea of numeric integration. We've kind of talked about the idea of finding an antiderivative and using this notion of indefinite integration. Um, but calculus answers two very important questions. The first question is how do we find the instantaneous rate of change of something, and then we were able to figure that out with our study of derivatives. We're now ready to answer the second question of calculus, and that is how to find the area of irregular regions. Now, you all know how to find the area of certain, um, shapes. For example, if I draw some type of triangle there, well, I'm pretty confident that you can tell me what the area of this triangle is if I were to give you some numbers. You would just say, oh, well, the area is equal to 1/2 the base times the height, and we'd be done with that. If I gave you a rectangle with length and width, you could easily tell me that the area here would be just length times width. So these shapes are pretty nice because we've seen them all along. We've seen them since we were, in elementary and stuff. But before we start talking about areas under curves, what I'm going to do and what I'm going to talk about here is something called summation. Okay, so let me talk about that really quick. Sorry about that. I had to cut off the video there. I'm here in class, and you know how they make announcements so randomly after school when nobody's here. So anyway, I'm going to start you off with this here. We have that S is equal to, and I'll explain what all this means in just a bit. So we have that S is equal to I, from I equals 1 to, let's say, I don't know, N of A sub I. Now this might look foreign to you right off the bat, but really this is just a sum. So this fancy symbol that you see here stands for sum, and notice that's why I put an S here for sum. And we are going to sum up a sub I, where I is equal to 1, all the way to n. So remember, when we sum up, we're adding. So essentially all this is going to be equal to is a1 plus a2 plus a3 plus a4. And you can kind of think about this same pattern going on and on and on, dot dot dot, all the way to some n. And this right here is our stopping point. So just to kind of understand this notation here, this right here, this is called a sum, right? We're calling this a sum. We're adding up all these terms here. This guy right here is called our index. So we are starting at 1. This is telling us our starting point. So we are starting when I is equal to 1. And then here, this right here, this is our upper limit. We call it an upper limit. But you can kind of think about this as this is where we're going to end. This is where we're going to stop, right? Also known as our upper limit. All right, there we go. And then you have this wonderful thing here, a sub I. Well, this a sub I is our rule. You can think about this as our function. It tells us what to do. So that is our function. And then notice that I just plug in. So I start off with 1, and I'll take this 1 and I'll plug them in there. And so we get a sub 1. Then what I'll do is I'll take the next number, which is a 2. I'll take the 2 and I'll plug them in there again, and then I get a 2. And I keep doing that, and then I get a 3, and then I get a 4. And I go all the way until I get to my upper limit. So that's all this thing means. Whenever you see this notation here, it's just telling you to add up a bunch of terms, and you got to follow this with your function. You got to follow the rule here. So here's a quick example. Here. So if you have this, the sum or sigma, and I didn't mention that earlier, but this is actually a Greek letter, and it's called sigma. So a Greek letter, and it is called sigma, and it stands for sum. So we're going to use this to symbolize that we're going to be adding a bunch of things. But anyway, back to our example. If I ask you to evaluate, so I want you to evaluate I equals 1 to 3. So maybe I should put here evaluate this. So find this for me. So I want you to evaluate from I equals 1 to 3. Here's the function I squared, and I want to know what does that equal. Well, keep in mind that our starting value, right? Our starting value is 1. So we will start at 1. Well, what does that mean? Well, that just means that we plug in a 1 just like we did up here. We plug in a 1 into our function here. So then I'd have 1 squared. And then I'm going to add. Well, what's after 1? Well, the next term would be 2, so I'm going to plug in 2 right there. And so I would have 2 squared. Again, I'm just following the rule because the rule says something squared, I squared. Then finally I plug in a 3, and so I would have plus 3 squared. And I stop at 3 because remember, 3 right here is my upper limit, right? This is the end. This is the start and this is the end. So I would stop at 3. And then all I have to do is just evaluate this, and this is pretty easy to do. 1 squared is just 1, plus 2 squared is just 4, plus 3 squared is, I don't know, 9. And then if we add up all this stuff here, we get the number 14. So it turns out that this thing here is just equal to 14, right? It's the sum of the first 3 terms, or 1, 2, and 3. We could do another example, but I'll save that for another video. I just kind of want to keep these videos short and brief. This is part 1, so make sure you go to part 2 when we start talking about areas under curves and how we can actually use this idea of summation to help us find an area under a curve.